Here we go, mathletes. Section 5.2 in the book, talking about perpendicular and angle bisectors. And we've talked about angle bisectors before. So now we're going to add perpendicular to the angle bisectors. So they'll be perpendicular and they'll be bisectors at the same time. All right, and so a perpendicular bisector is just like it says, right? It's a line that's perpendicular to a given segment at its midpoint, right? So in other words, it bisects the segment. It cuts it into two equal parts or congruent parts, but it's also perpendicular at the same time, right? So just to kind of real quickly show you, you can have lots of different bisectors, right? You can have a bisector, like if, let me actually start all over. You can't bisect a line, right? Because the line goes forever in both directions. But so if you have a segment and this is the midpoint, you can bisect it with a lot of different lines, right? In fact, an infinite amount of lines, right? You could have these lines go, every which way, but there's only one perpendicular bisector. So it's a line that crosses through that midpoint and is perpendicular to the segment. All right, so here we're going to prove theorem 5-2, perpendicular bisector theorem, which says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. Okay, so if a point is on the perpendicular bisector of the segment, then it's equidistant from the endpoints of the segment. Now, equidistant, I don't know if you've heard that word before, but it kind of means like what it sounds like. So equidistant means equal distance, right? It means they're the same distance away from those particular endpoints in this case, okay? All right, so here we have a situation we're given basically what the hypothesis is, right? And we're trying to prove the conclusion of this conditional statement. So we're given that PM is perpendicular to AB, right? That's our first given, and we can write that in while we're thinking about it. So PM is perpendicular to AB. And then we know that also PM bisects, line PM bisects AB. Okay, so the fact that it bisects means, right, that we're going to have those two congruent parts, or that crosses at its midpoint, right? So we'll have to take it a little bit further to say the congruent statement there. All right, so those are our givens. All right, and hopefully by now you're kind of understanding that, kind of whatever you're given kind of leads you to the next step a lot of times. So if we're given perpendicular, then we probably want to say that this is a right angle, right? So then I'm going to say angle PMA and angle PMB are right angles. Okay, and that's because of definition of perpendicular. Okay, and that opens up a few different doors. It opens up the door that we can call those congruent, and we can use one of our three-part theorems or postulate, right? ASA, SAS, SSS, so forth, AAS, or the other possibility is hypotenuse leg, of course, right? All right, and so in this case, with these triangles, I'm trying to prove that AP is congruent to BP, right? I'm trying to prove that this is congruent to this. So it probably makes sense that we probably want to prove that these triangles are congruent, right? And so if that's the case, then I can see that I can do this by reflexive property, right? We'll say that in a second. And then I already, we talked about that these are congruent. We'll have to say it in our statement. So I probably want that these angles are congruent, right? Because then I can have side angle side. So just kind of brainstorming and strategizing here. So I'm going to say, I just said that they're right angles. Now I'm going to say they're congruent. Angle PMA is congruent to angle PMB because all right angles are congruent. Okay. Then we can say, if we're given a bisector, then we know that we're making two equal parts, right? So now we can say that segment AM must be congruent to segment MB. Okay, so now we got this. Even though that was already mentioned or already shown in our picture, we still have to state it, right? Because we're just given the bisects, not the congruence statement. So that's definition of bisector, segment bisector. Okay, and then for step 5, we can use the reflexive property and say, hey, PM is congruent to itself, right? And so those two triangles share PM, so that's why this is beneficial by reflexive property. All right, and now we can say that those triangles are congruent by side, angle, side, right? We have side, angle, side with side, angle, side. All right, so I'm going to say triangle AMP is congruent to triangle BMP. Make sure we get the order right? A goes with B, M goes with M, P goes with P in this case. And that's because of SAS. And now we can say, okay, well, if those triangles are congruent, that must mean these sides are congruent because corresponding parts of congruent triangles are congruent, right? So AP must be congruent to BP because of CPCTC. All right, now we just proved theorem 5-2. All right, so let me know if you have any questions on that one. And real quickly, just to summarize, what we just proved is if we have a point that's on a bisector, then it's going to be the same distance away from the two endpoints, right?